So in the last video, we learned how to determine the number of significant figures in a value, and we also learned the concept behind significant figures, why you need them. In this video, though, we're going to take that idea and run with it, and we're going to make it practical to the labs that you will conduct in chemistry class, right? Because in your lab notebooks, you're going to be recording different masses or lengths or whatever else, right? You're going to be recording data. And the problem is, at the end of the lab, you're going to have to do calculations with that data to obtain whatever you're looking for, that is the end result. And so you have to use significant figures in a little bit different way than just, well, how many sig figs does this number have? You're going to have to add and subtract. You're going to have to multiply and divide. The problem is you have to do that with significant digits in mind. Let me show you how to do that. So now we're going to take a look at addition and subtraction. We'll move over to multiplication and division in a different slide. Here's the rule. When you're adding or subtracting and you want to keep significant figures, which I'll just tell you, you have to at all times in every lab that we do, you round the result to the same number of decimal places as the original number with the fewest decimal places. So let me show you what that means. Take a look at example A, okay? You've got 1.0023. So in this number here, you have 4 numbers to the right of the decimal, right? 4 numbers to the right of the decimal. And you're going to add that to 4.383. And in this number, you've got 3 numbers to the right of the decimal. But the rule for addition and subtraction says you're going to round your final result to whichever original, or you're going to round your final result to the number of decimal places as the number with the fewest decimal places in the beginning. So that means you're only going to have 3 numbers to the right of the decimal in your final answer. So take a look here for A. Again, you've got this value here, which has 4 numbers to the right of the decimal, but this number only has 3 numbers to the right of the decimal. That means after you do all of the addition, you're not going to shave any number off. You're going to plug it in your calculator as it is, right? And you're going to get this number. But that means you can only have 3 numbers to the right of the decimal. So you have 5.3853, so we're going to have to shave off this 3 here. Now because this 3 is less than 5, it's going to round down. So that means you can get rid of that 3 and you're going to have 5.385, right? So you have to round the final answer to the same number of decimal places as the original number given to you in the problem with the fewest decimal places. This one had 4, this one had 3. That means your final answer, right, even though you're plugging everything in the calculator, after you do that, you still have to shave it down to 3. Now let me comment on this though. Say that you would have gotten over here 5.3855. Well, you can still only have 3 numbers to the right of the decimal, so this 5 would have to go away, but in this situation, it'd be 5.386, right? Because this number here is 5, right? So if it's 1 to 4, you round down, and if it's 5 to 9, you're going to round up, and you learned that in elementary school, all right? So now let's get some more practice, but first let's clean this board up just a little bit, and let's take a look at part B. And part B is simply asking you to do a subtraction problem, which is not a big deal. So let's go ahead and, whoops, sorry about that. Let's go ahead and take a look here at part B. 486 minus 421.23. So, don't worry about the rules right now. You plug the numbers in as they are given to you in the calculator. So you're going to plug in your calculator 486 minus 421.23. You don't do any rounding or any work as far as the significant figures go until you've got the answer already performed in your calculator, right? So you plug that in and it tells you 64.77. But here's the problem, right? You have to look at the original number with the fewer decimal places to the right. And so in this one, 486, right, you have 0 numbers to the right of the decimal. And in 421.23, you've got 2 numbers to the right of the decimal. So obviously the smaller number is the 0. So that means in your final answer, right, what it means is whatever number your calculator gives you, you're going to have to shave it off to where there is 0 numbers to the right of the decimal. So, it can't be 64 point something. It's going to either have to be 64 or 65. You can't have any numbers to the right of the decimal. So, 7 is greater, is 5 or greater. And so this is going to round to 65. And that will be the correct answer. Now, taking a look, let's move over to multiplication and division. So this rule is a little bit different. When you multiply and divide, you don't have to worry about the decimal or the numbers to the left or to the right of the decimal. That doesn't matter. This is a little bit easier to me. It's why we're covering it last. When we multiply or divide, you round the result to the same number of digits as the number with the overall fewer ones. That's a whole lot easier, right? So let's just go straight to A. You're going to multiply 0.6238 by 6.6. Now this is not adding and subtracting. We are not concerned with the numbers to the right of the decimal or the amount of numbers to the right of the decimal. We are only concerned about the smallest original number given. And of course, that's the 6.6. But even then, we're going to plug all of this in the calculator just as it is. We're not going to shave any number off. We're not going to cut any number off until we have it done in the calculator. That is all the time. Whether you're adding, subtracting, multiplying, or dividing, don't you ever cut off any number, do any rounding before you do your calculation, because that makes the number way less accurate. It makes it useless. Only worry about the sig figs after you've got the calculation performed. All right? So we're going to put that in the calculator, and here's what we get. All right? You get 4.11708. But the problem is your final answer can only have the same number of significant figures as the original number with the smallest numbers. Again, you're not worrying about to the right of the decimal. You're just worried about the overall original smallest number, which we said was 6.6. And 6.6 is 2 numbers. Again, we're not worried about, let me just make a note of that. Not worried about numbers right of the decimal. We're worried about the total number. So this has 6.6 has 2 numbers, so that means your final answer, again, can only have how many numbers? 2 numbers. And it doesn't matter about whether it's right of the decimal or whatever. So, the only way we can round 4.11708, well, is just say 4.1, right? That's 2 numbers, and we're good to go. So cleaning the board up here, let's go ahead and do the division problem, I do believe is next. And then we'll be good to go, my friends. So again, we're going to put all of this in the calculator. You're going to do your division first. You're not going to shave off any number. So once you get that value in your calculator, which to check your work should be 0.86728, now is when we worry about shaving some numbers off to get correct sig figs. So again, we're only worried about the overall smallest number, not about how many is to the right of the decimal or whatever. That's addition and subtraction. So you got 421.23, that's 5 numbers, and 486, which is 3 numbers. That means our final answer can only have 3 numbers because that's the overall smallest number originally given. So you've got 8 6, and 7. The 2 after that will round down. That means it's just 0.867. Now let me show you one more time. If this would have been 0.867, to get this to 3 sig figs, you'd had to have said 0.868. So those are the rules for addition, subtraction, multiplication, and division.